So here's two bad toolpaths for your delight. This first one is a 2D adaptive, where I ramp down to the bottom of a pocket to clear it out at full flute depth. And the final thing here is a 2D contour. So there's two subtle things wrong here. First of all, this helix angle is way too steep for almost any end mill. So if you were to do this in aluminum, you would probably instantly clog up the end mill, and the chips would weld to the end mill, and the spindle would come to a grinding halt, and it would be terrible. The second thing that you might not notice just looking at this toolpath, if you didn't simulate it, is that this plunge move actually happens below the top of the stock. So if I hide all of this, it's actually above the model, but it's not. But it's below the stock. So it's actually going to plunge right down, and just that first few, like maybe 1/16 of an inch, it's just plunging directly into the material. I actually notice this in other people's programs a lot, and sometimes I don't say anything. It accidentally happens a lot more than you would think for a variety of reasons. So if you were to simulate this, all you would see is that in Fusion. If there's a way to get a list of all of the collisions in Fusion, maybe someone can post that in the comments. I don't use Fusion enough. But this issue of having the beginning of your ramp lower than your remaining stock is common to all programs. So that was what I wanted to address with that. And then the other thing, just really quickly, I want to point out that you can control the smallest radius for these roughing operations, like this 2D adaptive contour, and that will control how much you leave in these tight little corners. If you have, if you're machining something like this part that actually has no radius on it in the actual model, this is a problem for two reasons. One is that when you go in with this final 2D contour, which I have here, when you get into this corner, at least in a difficult material, you're going to be engaging quite a bit of the cutter. And that really leads to chatter in machines that aren't perfectly rigid, which includes ours. And it also requires more torque and things like that. So the servos can start to act a little weird in the corner. So I really wanted to point that out. If you're designing parts, think about what end mill you're going to use and make this radius bigger than the radius of your end mill. So 1/2 inch end mill, a radius of like 0.28 is enough to prevent problems. But if you have to cut it really close, just make sure that your adaptive is clearing out enough material that if you leave, like, say, 20 thou stock on the side to clean up with your finishing pass, you come in to the corner and you don't have like way more than that. Again, that's mostly for difficult materials. The last thing here is I've left stock to leave on the floor of my part here, and then my 2D contour comes in and plunges right down into the stock that's left on the bottom. Common problem. All right, that was a quick video.